This video will cover section 5.7, factoring by special products for Math 95. Our main goals are to factor a perfect square trinomial and factor a difference of squares, but we're also just going to get in some more practice. We're going to start by factoring a couple of perfect square trinomials, but what you're going to see is that factoring these guys is just like factoring all the other trinomials you've learned to factor so far. In my first trinomial, I have x squared minus 14x plus 49, so a times c is 1 times 49, which is just 49, and my b is negative 14. So I'm looking for things that multiply together to be 49, but add together to be negative 14. And in this case, it's kind of nice, since 49 is a perfect square, there's only a couple things to consider. I've got 49, 14. The two things that will multiply together to be 49, but add to be negative 14, are negative 7 and negative 7. So now I have two options here. I can continue going along with my factoring by grouping method, where I write down x squared minus 7x minus 7x plus 49, group my two sets of terms, factor out the thing that they have in common. In this case, it's an x, and in this case, it's going to be a negative 7. And now I'm left with a term that has an x minus 7 and another term with an x minus 7. So I pull that x minus 7 out, and I'm left with an x minus 7. The other thing that I could have done would be to notice that because my lead coefficient is 1, now that I found the two things that multiply to be negative 49 but add to be negative 14, I can actually skip down to this last step and just write x minus 7 multiplied by x minus 7. But remember, that's only because the lead coefficient here is 1. If it was anything else, I really would need to go through this factoring by grouping process. Finally, when I look at my answer, I have x minus 7 multiplied by x minus 7, which you may have noticed is the same as x minus 7 quantity squared. Now it's fine with me if you write this x minus 7 squared, or x minus 7 multiplied by x minus 7. But you should notice that this is x minus 7 squared. And that's really all we mean by factoring a perfect square trinomial. We just mean that when you factor it, it turns out that it was actually a perfect square to begin with. Now there is a sort of a pattern to these perfect square trinomials, which you can read more about in your book if you want to. I encourage you though, rather than looking for the pattern and trying to notice whether it's a perfect square trinomial to begin with, just factor it the way that you would factor any other trinomial that you encounter, and if it happens to be a perfect square, great. Now let's go ahead and look at this second example. X squared plus 6x plus 9. Now a times c will be 1 times 9, which is just 9. Notice that my a is 1, so I'm going to be able to use that nice little shortcut. And my b value is 6. So I'm looking for things that multiply together to be 9, but add together to be 6. This time it's going to be positive 3 and positive 3. Now, because my lead coefficient here is just 1, I can skip straight to the punchline and write this as x minus 3, or rather x plus 3, multiplied by x plus 3. Or, since it's x plus 3 multiplied by itself, I can write this answer as x plus 3 squared. Next, we're going to look at factoring the difference of two squares. And again, we're just going to jump in and factor a couple things and see what happens. Let's start with this example, x squared minus 36. Now my a times c is 1 times negative 36, which is negative 36, and my b is 0, since there isn't a middle term. So we're looking for two things that multiply together to be negative 36, but add together to be 0. Can you think of anything? Remember that if you're getting stuck coming up with factors, you can always make a list off to the side of all the possible factors. So negative 36 could be made by negative 1 times 36, 2 times 18, because one of them has to be negative, negative 3 multiplied by 12, negative 4 multiplied by 9, negative 6 multiplied by 6. Aha! That's one that will add together to be 0. So negative 6 and 6 are my two magic numbers. Now that I have those two numbers, remember that I use them to uncombine my middle term. So I take my x squared minus 36 and write it as x squared minus 6x plus 6x minus 36. And now we'll go ahead and do that factoring by grouping. So I group my first two terms together and my last two terms together. Then I look for something that I can factor out of each group. In x squared minus 6x, I can factor out an x, and I'll be left with x minus 6. And in my second group, I can factor out a 6, and again I'll be left with x minus 6. So now I've got x times x minus 6 plus 6 times x minus 6. They both have an x minus 6 in common, so I factor out that whole x minus 6, leaving behind an x from the first term and a plus 6 from the second term. And there is my factorization. Remember that you could always multiply that back out to make sure that it works. Did you notice that back at our original, we had x squared minus 36, which is 6 squared. So this was a difference of squares, x squared minus 6 squared, and my answer came out as x minus 6, x plus 6. That pattern might be useful to know. With that in mind, let's go ahead and look at my next example. I've got 4x squared minus 9. Now, 4x squared is the same as 2x being squared, and 9 is the same as 3 being squared. So this is also a difference of squares. Let's see if we get the same kind of pattern that we found down here. We'll go ahead and start by going through the same a times c method. So a times c here is 4 multiplied by negative 9, which is negative 36, and there's no middle term, there's no x, so my b is 0. So I'm again looking for things that multiply to be negative 36 but add to be 0, and we just figured out that those have to be negative 6 and 6. So then I use those two terms to uncombine my middle term, giving me 4x squared minus 6x plus 6x minus 9. And then I group my terms so that I can do factoring by grouping. From my first group, I can factor out, I think, a 2x. And I'm left with a 2x minus 3. And then from my second group, I can factor out a 3, which leaves me again with 2x minus 3. Now I have two terms. One is 2x times 2x minus 3, and one is 3 times 2x minus 3. They both have a 2x minus 3 thing, so I can factor that all the way out, 2x minus 3, and I'm left with a 2x from the first term and a plus 3 from the second term. And do you notice that we've ended up with the same sort of pattern that we did on the first example? Here I had x squared minus 6 squared, and my factorization ended up as x minus 6, x plus 6. Here I had 2x squared minus 3 squared, and my factorization ended up as 2x minus 3, 2x plus 3. This pattern is consistent. To explore it a little bit further, let's look at what happens when we multiply something of the form a plus b times a minus b. So I'll go ahead and FOIL this out. A times a is a squared. A times negative b is negative ab. B times a can be plus ab. And b times negative b is negative b squared. Now those two middle terms are going to cancel out. Negative ab plus ab cancel out, and I'm left with a squared minus b squared. So the two middle terms canceled each other out, and what remains looks like a squared thing minus another squared thing. What this is telling us is that whenever you start with one squared thing minus another squared thing, you know already that it's going to factor as the one thing plus the other thing times the one thing minus the other thing. In mathematics, we often write that out as a little formula. A squared minus b squared is the same as a plus b times a minus b. But all that really means, again, is if you have one thing being squared minus another thing being squared, or a difference of squares, then you know that it'll factor as the one thing plus the other thing times the one thing minus the other thing. Now, I'm not a big fan of memorizing formulas, but this factoring a difference of squares formula is one that I find really helpful to have on the top of my head. I sort of expect that as you practice, you're not going to be able to help but end up remembering it because you'll use it so often. However, if you ever forget it or you're not sure, you can always factor using that A times C method from section 5.4. Just remember that your middle term, b, is 0. Now I've got two problems for you to try. So go ahead and pause the video and then try factoring each of these two differences of squares. Then come back and we'll see what you got. And we're back. Let's go ahead and look at these examples together. First I have x squared minus 49. X squared is x squared, and 49 is 7 squared. So this is a difference of squares, which means that it will automatically factor as the one thing plus the other thing, x plus 7, times the one thing minus the other thing, x minus 7. Now notice that it doesn't actually matter which order I write those two factors in. I could just as easily write it x minus 7 times x plus 7, and it would mean the same thing. In my second example, I had 4y squared minus 81. I noticed that 4y squared is 2y squared, and 81 is 9 squared. Now that I've identified the two things that are being squared, I can plug it straight into my little formula. I'll have 2y plus 9 times 2y minus 9. Now that you've learned how to factor a difference of squares, you've learned all of the factoring techniques that we're going to learn in this class. So my next slide here is just a summary of how to go about factoring anything you encounter. Your first step when you're trying to factor something is to see if there's a greatest common factor that you can factor out. For example, here I have x squared y cubed plus 3xy cubed plus 2y cubed. All those terms have a y cubed in them. So I can go ahead and factor out the y cubed, leaving behind x squared plus 3x plus 2. Now as a sort of an aside, I'd like you to notice that this x squared plus 3x plus 2 can be factored further. So once you've factored out the greatest common factor, check and see if you can factor anything else that remains. This guy actually factors into y cubed multiplied by x plus 1 times x plus 2. Once you've factored out the greatest common factor, your next step is to look at the polynomial that remains and see how many terms it has. If it has 2 terms, check to see if it's a difference of squares. For example, x squared minus 9 has 2 terms and is actually a difference of squares, so this factors as x plus 3, x minus 3. If your polynomial has 3 terms, try factoring it using the a times c method. For example, here I have 2x squared minus 5x minus 3. A times c is negative 6, and my b is negative 5, so I'm looking for things that multiply to negative 6 but add to negative 5. That's going to be negative 6 and positive 1. Then I split my middle term up, making this 2x squared minus 6x plus 1x minus 3. And then I factor by grouping my first 2 terms together and my last 2 terms together, and seeing if there's anything I can factor out of the groups. In my first group, I can factor out a 2x, and I'm left with an x minus 3. And in my second group, they don't have anything in common, but I can think of there being a little ninja 1 in front that I can pull out, making this 1 times x minus 3. And then finally, I have an x minus 3 in both of my terms, so I can factor that out, giving me x minus 3 times 2x plus 1. If your polynomial has 4 terms, you're going to try factoring by grouping just right away. Here I've got 2x cubed minus 6x squared plus x minus 3. So I'm going to go ahead and group the terms. I look at my first set of terms and see that I can factor out a 2x squared, leaving behind an x and a negative 3. And in my second set of terms, they don't have anything in common, but I can still think of that as being plus x minus 3. Now both my terms have an x minus 3 in them, which I can factor out, leaving me x minus 3 times 2x squared plus 1. Remember that I need a placeholder 1 there, so that I'll get the same thing back when I multiply it all back out. Finally, your last step is to check and see if any of your factors can be factored further. For instance, up here at the top, we noticed that after I had factored out a y cubed, I could continue to factor the thing that was left. Let's go ahead and summarize this really quickly. If you're asked to factor something, the first thing that you're going to do is factor out the greatest common factor. Once you've done that, you're going to look at the polynomial you have and see how many terms it has. If it has 2 terms, look and see if it's a difference of squares. If it's not a difference of squares, then we don't have any tools for factoring it, and we'll just stop. If your polynomial has 3 terms, you'll factor it using the a times c method. And if it has 4 terms, you're going to try factoring it by grouping. And then finally, once you've done some factoring, you're going to go back and look at every single factor that you've got and see if any of them can be factored further. Once you're sure that none of the factors you have can be factored anymore, you're done. Because this section sort of wraps up factoring for us, I'd like to end by doing several examples of factoring. I'm going to start with this example. I have 4x squared y cubed minus 4xy cubed plus y cubed. Now I'm going to start going down my list. The first thing I do is see if there's a common factor. And indeed, these guys all have a y cubed. So I'll factor out the y cubed first, which leaves me with 4x squared minus 4x plus 1. Now that I've factored out the greatest common factor, I'll go ahead and look at what's left and see if I can continue factoring it. This is a trinomial. It has 3 terms, so I'm going to try using the a times c method to get it to factor. So I look at my a times c, which is 4 multiplied by 1, which is just 4, and then my b is negative 4. So I'm looking for things that multiply together to be positive 4, but add together to be negative 4. Now with 4 and negative 4, there aren't really a lot of options for factors, so I can probably run through them in my head. It looks to me like negative 2 and negative 2 will work, because those two negatives will multiply together to be positive 4, but they'll add together to be negative 4. So now I take those two numbers and use them to uncombine like terms for my middle term here. So I have 4x squared minus 2x plus 1. And I like to keep writing that y cubed as I come down, otherwise I tend to... So for my next step, I'm going to group these terms into 2 groups, and then I'll look at my first group and see if I can factor anything out. It looks like there's a 2x in common, so I'm going to factor out a 2x, which leaves me with a 2x and a minus 1. Looking at my second group, I'm going to factor out a negative 1, because I see that the first term in my group is negative. It's a good hint, or a good trick. Anytime you see that the first term in your group is negative, factor out a negative number. So this factoring out negative 1 leaves me with 2x minus 1. And then, just so that I don't forget, I'm going to write that y cubed along the outside here. Now I look at my sets of terms here. I have a 2x multiplied by 2x minus 1 and a negative 1 multiplied by 2x minus 1. If I pull that 2x minus 1 out, I'm left with a 2x from the first term and a minus 1 from the second term. And then don't forget that y cubed that comes along for the ride. Finally, I can leave it like this, or I can notice that I have 2x minus 1 multiplied by itself and write this as y cubed multiplied by 2x minus 1. Now let's take a look at this second example. I have 1/4 x squared minus 9. First I look to see if they have any common factor, but they don't have anything that goes into both of them, so I've already dealt with the greatest common factor part. Next I look to see how many terms it has. This has 2 terms, which makes me ask the question, is it a difference of squares? It sure looks promising. 4 is a square, x is being squared, 9 is a square. I'm going to go ahead and take that one right now. That's the same as 3 squared. And 1/4 x squared is the same as 1/2 x being squared. So this is a difference of squares, which means that I can use that difference of squares formula to write this down as 1/2 x plus 3 multiplied by 1/2 x minus 3. Finally, let's have a look at this last example, 12x squared plus 25x minus 7. Now, these terms don't have anything in common, so I don't need to worry about factoring out the greatest common factor. My next step is to look and see how many terms there are. This has 3 terms, so I'm going to try factoring it using the a times c method. My a is 12 and my c is negative 7, so a times c is 12 multiplied by negative 7, which is negative 84. So I'm looking for things that multiply together to be negative 84, but add together to be 25. For me, nothing jumps out at me that multiplies together to be negative 84, but adds together to be positive 25. The things that I do notice, though, are that negative 84 is negative, which means that one of my two things will be negative and the other one will be positive. 25 is positive, which means that the smaller number here is going to have to be negative, so that when I add them together, I end up with an actual positive number here. Now I'm going to start listing all the factor pairs for negative 84 that I can think of, with the smaller number being negative. So we have negative 1 and 84. We have negative 2 and 42. Let's see, is it divisible by 3? It is, so negative 3 and 28. Ooh, that one looks like it's going to work. Negative 3 plus 28 is 25. So there's my two numbers that multiply together to be negative 84, but add together to be 25. Now that I've found my two numbers, I can uncombine that middle term, making this 12x squared minus 3x plus 28x minus 7. Then I factor by grouping. So I'll group my first two terms together and my last two terms together. I'll look at my first group to see what they have in common. It looks to me like there's a 3x that can come out of there. When I take a 3x out of 12x squared, I'm left with 4x. And when I take a 3x out of negative 3x, I'm left with a negative 1. Remember that you can always check this by multiplying it back through really quickly to see if you get back to what you started with. In this group, 28x minus 7, it looks to me like I can pull a 7 out. So this is going to be 7 multiplied by, I think this gives me a 4x, and this is a negative 1. Now when I look at my groups here, I have 3x multiplied by 4x minus 1 plus 7 multiplied by 4x minus 1. They both have a 4x minus 1, so I can pull that all the way out. When I take 4x minus 1 out of the first term, I'm left with a 3x. When I take it out of the second term, I'm left with a 7. So there's my final factorization. Again, remember that you can check your work by multiplying this back out to see if you get back to what you started with. Of course, I can't end the video without giving you a chance to practice. So go ahead and pause the video, try factoring each of these three expressions, and then when you're ready, play the video up again and we will compare answers. And we're back. So for this first example, I had x squared plus 8x plus 16. So I noticed that they didn't have any common factors, so I didn't need to factor out the greatest common factor. And then it has three terms, so I'm going to try the a times c method. A times c was 1 times 16, which is 16, and my b is 8. So I'm looking for two things that multiply to be 16, but add to be 8. And I realized that those had to be 4 and 4. Then I took one step further and realized that my lead coefficient here was 1. The value of a was 1, which actually means that the 4 and the 4 are the two numbers that are going to end up right here in my factorization. So this is x plus 4 multiplied by x plus 4. Or, if we're being fancy, we can write it as x plus 4 squared. My second example is 18x squared y minus 2y. This time when I look at it, I realize that in fact these two terms do have something in common. They both have a 2y. So I started by factoring out the 2y, which left me with 9x squared minus 1. Again, don't forget that placeholder 1 there, it's important. Now I can pause, look at my polynomial that remains, and see if I can do anything with that. This has two terms, so I'm going to check and see if it's a difference of squares. The 1 is definitely a square. 1 is 1 squared. 9x squared looks promising, since 9 is a square and x squared is definitely a square. 9x squared is the same as 3x squared. So this is a difference of squares, which means that I can plug it right into that little formula. 3x plus 1 multiplied by 3x minus 1. And don't forget to bring down that 2y. It needs to stay along for the whole ride all the way to the end. The last example here is possibly one of the trickiest. This is 21x squared minus 22x minus 8. I don't see that they have anything in common, so I'm not factoring out a greatest common factor. It has three terms, so that means I'm going to try the a times c method. A times c is 21 times negative 8, which is a negative 168. B is negative 22. So I'm looking for two numbers that multiply to be negative 168, but add to be negative 22. So what I notice about that right away is that if my two numbers are going to multiply to be negative, one of them will be negative and one will be positive. If they're going to add together to be a negative number, the bigger number is going to have to be the negative. So I didn't know which two numbers that was going to be right off the bat, so I made a list of possible factors over here. 1 times negative 168, 2 times negative 84, and so on, keeping the bigger number as the negative so that I could more easily see whether they would add together to be negative 22. When I got down to 6 and negative 28, I saw that those two will add to be negative 22. So those are my two numbers, finally, 6 and negative 28. Then I use those to uncombine the middle term, making my original 21x squared plus 6x minus 28x minus 8. And then I group my terms into two groups. Looking at my first group, I see that they have a 3x in common. So I factor out the 3x, leaving me with 6x plus 2. In my second group, I see that there's a 4 in common here. Because my first term is negative, I'm going to go ahead and pull out a negative sign along with that 4, making this negative 4 multiplied by 7x plus 2. Now my two terms both have a 7x plus 2 in them. So I pull that whole 7x plus 2 out. When I take 7x plus 2 out of the first term, it leaves behind a 3x. And when I take 7x plus 2 out of the second term, it leaves behind a negative 4. So my final answer here is 7x plus 2 multiplied by 3x minus 4. Now at the end of a long, complicated problem like that, you may want to multiply that thing back out just to make sure that you really did get the right factorization in the end. So that's it for this section, guys. Happy factoring!